Probability Part 2. We're going to talk first about mutually exclusive events. Two events, A and B, are said to be mutually exclusive if the occurrence of one of the events excludes the possibility of the other event from happening. Example 1. The event of drawing a red ball or drawing a ball marked 1. If you look at these two events, they're mutually exclusive events. If you draw a red ball, you can't get a ball that's marked 1, right? And vice versa, if you draw a ball marked 1, it excludes the possibility of having a red ball. So these two events are mutually exclusive. Let's look at another example. Example 2. Take the two events of drawing an odd numbered ball or drawing a red ball. Drawing an odd number ball does not exclude the possibility of drawing a red ball. In other words, they can both happen at the same time. You can draw a 3 and that's an odd number ball, and you also have a red ball. And vice versa. You can draw an odd red ball and get an odd number ball. Thus, these two events are not mutually exclusive. Now this is important because when we talk about OR type probabilities, which we will, here it is, OR type probabilities. The probability that events A and B happens is the probability that A happens or B happens, which equals the probability of A plus the probability of B minus the probability that both A and B happen at the same time. When A and B are mutually exclusive events, the probability that A and B happen at the same time right here equals 0, and we only have to look at the probability of A plus the probability of B. Important. The probability of A or B equals the probability of B or A. You can switch them around. Okay, let's see what we've got here. Find the probability of drawing a yellow ball or drawing a 3. Well, we look at this thing, a yellow ball or a 3. Now if you draw a 3, it excludes the possibility of having a yellow ball, and vice versa. If you draw a yellow ball, you're not going to have a 3. So these events are mutually exclusive. We really have to worry about just the sum of the two probabilities. The probability of drawing a yellow ball or a 3 equals the probability of drawing a yellow ball plus the probability of drawing a 3. Of course, there are 2 yellow balls out of 5, so the probability of drawing a yellow ball is 2/5. There is 1 3 in the whole bunch, and there are 5 balls, so that's 1/5. We add them up and we get 3/5. And that's the probability right here of drawing a yellow ball or a 3. Let's look at one more example. Find the probability of drawing a red ball or drawing an odd number ball, essentially. I don't have that. I probably should put that, shouldn't I? Odd number ball, B-A-L-L. These events are not mutually exclusive because it's possible to draw both a red ball and an odd number ball at the same time. You could draw a 5, right? So the probability of drawing a red ball or an odd number ball equals the probability of drawing a red ball plus the probability of drawing an odd number ball minus the probability of drawing a odd red ball, red and odd, right? So let's see what that is. Okay, got to get rid of that. The probability of drawing a red ball is 3 out of 5. So I'll put a 3 here and I'll put 5 here. The probability of drawing an odd number ball, how many odds? There's 1, 2, 3 odds out of 5. So this is 3 out of 5. And then the probability of drawing a red odd ball. Let's see how many there are. There's 1 red odd, 2 out of 5. And I think that comes up to 4 out of 5. So the probability of drawing a red ball or an odd number ball is 4/5. 4/5 of the time you will do that.